The most common scenarios for chemical reactions that need to be calculated are mole-to-mole conversions, which are relatively uncommon but very easy, mole-to-gram conversions, which are two-step conversions, and then the next slide will show the most common type, gram-to-gram conversions, how many grams of A are needed to make X grams of B, for example, and gram-to-molecule conversions. So let's go ahead and start with mole-to-mole conversions. For all of these conversions, it's important to recognize that those numbers in front, 2, 13, 8, and 10, are chemically as well as mathematically equivalent. They're powerful numbers. Every 2 moles of butane requires 13 moles of oxygen. It will make 8 moles of carbon dioxide, and it will make 10 moles of water. Watch how when we solve these problems, we use them as mathematically equivalent conversions. How many moles of CO2 will be produced from 1 mole of butane with plenty of oxygen? Well, every mole of butane will make 4 times as many moles of carbon dioxide. The answer is 4. If 2 makes 8, then 1 makes 4. Let's do this one with canceled units. This is what's usually called for on a test. How many moles of oxygen are needed to react with 17.26 moles of butane? Well, every mole of butane requires 6.5 times as many moles of oxygen, so that's all you're going to have to do. But why don't we do it nice and clean? Start with what you're given, your 7.26 moles of butane. Recognize that it's a one-step conversion, so give yourself one line and convert from your moles of butane to your moles of oxygen, putting those numbers in front. 13 over 2 is 6.5. A mole of butane divided by a mole of butane equals 1. The units cancel nicely. We need 112.2 moles of oxygen. If you have 0.42 moles of oxygen, how many moles of butane do you need? They're giving you the oxygen. They're asking you how much butane you need. I'd say roughly a sixth, but we better do it clean. Start with what you're given. Recognize that this is a mole-to-mole, one-step conversion. Circle them if you want, and write your conversion. Every 13 moles of butane only needs much less. 2 moles of butane, punch it in, and you'll see that this reaction requires 0.065 moles of butane. It's always surprising to me that they ask these problems because nobody really does this. You need to calculate what the mass is, but it's a good start. All right, two-step conversions. The combustion of 3 moles of butane right there with plenty of oxygen will make how many grams of carbon dioxide? Well, it will require 4 times as many molecules, or moles when you scale it up, and each one of them will weigh 44 grams, 12 times 32. So I got it in my mind more or less what I need to do, but let's write out a clean mathematical conversion. Yes, start with what you're given, 3 moles of butane. Recognize that this is a two-step conversion, mole to gram. Give yourself 2 lines. It's also a good idea to write where you're going to, and go ahead and write your grams of CO2 there. I didn't do it in that order, but that's what I'd recommend. Okay, I see these units. I'm going to blindly write them down there. Every 2 moles of butane, you better check where you're going to, CO2. So it requires 8 moles of CO2. Those units there, we're going to automatically write them so they cancel. So we've gone from moles of butane to moles of CO2, and then we'll go from moles of CO2 to grams of CO2. A mole of CO2 has a mass of 44 grams, so these are mathematically equivalent. Punch it all in, and you should see that this produces 528 grams of carbon dioxide. Here's another. If you've got 4 moles of butane, and that's what we'll write down since it's what you're given, how many grams of oxygen should you react it with? Moles to grams, two-step conversion. I'd write equals blank grams of O2 right there, but we'll get there. Every 2 moles of butane requires 6.5 times as many moles of oxygen, and every mole of oxygen, canceling those units, has a mass of 32 grams. Punch it all in after canceling your units like a good person. and you get 832 grams of oxygen are required for this chemical reaction. That's mole to mole and mole to gram conversions.